This is a metal track equipped with 1234 dictionaries, and the pair of magnets in front have the same polarity. Moreover, this pair of magnets has opposite polarity. A slider with a wire is placed in the middle, and when powered with 10 units, it becomes an electromagnet. It will be repelled by the pair of magnets in front and attracted by the pair behind, thus being propelled forward. Let's test it by powering it up. See that? The money in hand is gone, and the two items are replaced with metal bars, placed on both sides of the track. This also includes the same setup, with the poles connected to the back. The metal bar pushes forward, and as soon as the two pairs of metal contacts touch, it can power the coil. Slowly push it forward to see if it works. It works. The entire device is basically purely mechanical, without any complex circuits. However, these metal pieces don't seem to be perfect, and can't maintain good electrical contact. These slot cars have these kinds of brushes on the chassis. They can make good contact with the metal strips on the track, which allows them to power the motor inside and make it run fast on the track. I bought a pack, and there were only 6 in it. It cost a little over 3,000 for the basic pieces to cover the bend, wrap the brushes inside, and then connect the metal pieces to the two ends of the coil. After improving the slider, let's give it a try. Wow, it's really fast, and it indeed fits well, and has significantly enhanced. Now the number of magnets has been doubled, with a total of 4 pairs, increasing the number of magnets, and the number of contact points has also increased accordingly. When passing through reality, each pair of magnets can automatically switch poles. This way, with attraction and repulsion, there are a total of 4 enhancement points. The line points have also been simplified, making the whole thing narrower and lighter, which should allow for a faster start. I accidentally discovered this type of habitat. Although the price is similar to that of electric brushes, it comes in a roll, and looks quite similar, except the woven material is different. How about connecting the slider to the 2 poles of the clue, Lautan? Oh, this is even cuter. In the competition, don't go out yet. The sparks have left some residue on the metal piece above. The melting point of this chain is still relatively high, mainly it has melted. This copper wire looks quite fierce indeed, and upon closer inspection, you can see that the first pair of magnets generates a very strong repulsive force. Then the 3D printed parts on both sides twisted and deformed, causing the connection to be intermittent, with sparks flying all the way. Reprint the magnet mounting board using photosensitive resin. This material is more robust and should be fine. The ribbon is connected to the main wire, completing the C shape and fitting it into the reserve position top. The chain is also bent at both ends using a mold to make contact with the copper strip. In this way, if there is any damage later, it can be pried out easily, making it convenient to replace. For the rail separation distance, just shift a hole and drill a whole row, making it easy for the wires to pass through. By stepping on a long copper rod, you can supply power to all the contact points on it, install the magnet bracket, and weld the 2 poles of the contact points. All the positive connections are linked to this main copper rod, and all the negative connections are linked to another copper rod. Once the power lines are connected, and the slider is placed correctly, it works just by making contact. The effect is fine, and the speed has also increased. Continue to increase the number of magnets. A total of 80 characters, 80 in total. It took about 8 hours to fully assemble one contact point. A trigger device was 3D printed and assembled on the right, installed, first pressed down to latch it, including inserting it and pushing it to the initial position. When pressed, a problem was discovered. During 2-level touch, it would immediately bounce back. Although the human eye cannot detect it, in slow motion, it is clearly visible, which more or less affects the speed of the coil. You describe this dry yellow tube, also known as a reed switch, whose 2 contact points are very sensitive, but the current it can withstand is really too low. Here, a trigger switch was made anew, based on its principle. When you see the 2 words, wealth and honor, attracting each other, it allows the metal piece to make contact and successfully connect. Installing it on the track for testing is also completely fine, and the contact no longer rebounds. Finally, adding a protective plate to the 2 copper rods makes it even safer. Including placing a paper airplane in front, visual effect, 3, 2, 1, go, and then try with a grape. Place it. Wow, juice bursts out. Try placing several grapes to see. You see, there's a stock that went up very high. Did you see that? Try putting this dog sausage and watch in slow motion. It's like a money bug blocking it. I added a nose cone to the front of the skateboard, just like a train engine. Set it up and try it. Wow, it's so fast. Only through slow motion can you see clearly. Let's see this effect again. This sausage is really elastic. It perfectly absorbs energy, achieving softness, overcoming hardness. We made 4 sliders with different accelerations to test the differences between them. 100, 200, 300, and 400 are all equipped with printed tracking markers, allowing the software to calculate the specific speed. The voltages are 16 volts, 32 volts, and 48 volts respectively. Tested 3 times, the result was that the 200 megawatt coil was the fastest, crossing the finish line first. After calculations, the 400 megawatt initial thrust is the largest, but it is also the heaviest, which caused it to lag behind. The 200 megawatt coil, which achieves balance, can reach a maximum speed of 70 kilometers per hour. And the entire battery track structure is simple. There are no sensitive electronic devices. It's simply top-notch. This small foam plane weighs only 138 grams, and the battery track should be able to launch it into the air. A cradle was designed for it, based on the size of the fuselage, and after trying it out with a 3D print, it fits perfectly, simply perfect. Using 2 series of wires to propel it, place the small plane properly, go outdoors for testing, connect the power, and prepare to launch. See that? Easily done. The total weight of the small plane and the propulsion ring block is 220 grams, reaching a speed of 4.2 meters per second, which is roughly 37 kilometers per hour, much faster than the estimated speed. You can see that the propulsion coil can successfully detach due to gravity and does not interfere with the small plane, although this is not the most practical method for launching a plane. But it is the coolest and most fun.